Alright, so maybe it's all well and good when we have an animation of function assembly lines, but if we're faced with something like this in an exam, we need an approach to find the solution. So in this sample question, we are given two functions, f of x, which is linear, and g of x, which is quadratic, and we need to find the composition of these functions. In the first part, we need to evaluate the composition when our input is -1, and in the second part, we need to show that f of g of x in general is not the same as g of f of x, which just means that the order in which we arrange our function machines matters, but we'll see that when we get to it. So let's start with the first part. In the first part of the question, what are we doing? We are inputting -1 into f of x and g of x. But what's the order? Well, the first function that it's going to go through is g of x. So we saw in the last slide that it's the opposite to as we see it in the notation. So g of x is first rather than f of x. So don't make that mistake. And then the output of g of x will get sent to f of x. And the final output will be f of g of -1. So the first part then will just involve subbing in -1 into g of x. So we're looking for g of -1. Now g of x is just equal to x squared minus 2x. So we're just subbing in -1 for x. And what does that give us? -1 squared is 1, -2 by -1 is +2. So the output is 3. So that means that we are inputting 3 into f of x. So we're looking for f of 3. And f of x is just 2x minus 5. So we sub in 3 for x and get 6 minus 5, which is just equal to 1. So what does that mean? It means that f of g of -1, so the composition of f of x and g of x in that order, is just equal to 1. Okay, so the second part then, so we're showing that in general, if we sub in numbers first into g of x and then to f of x, that is not the same as if we sub our number first into f of x and then into g of x. So maybe it's tempting here just to use -1 again, except this time use f of x first and then g of x, but the question does say in general, which means we will want to find our composition in terms of x. So let's do that first, and we'll start with f of g of x. So f of g of x, remember, is the same as using the notation f bracket g of x. And I think this notation is actually a little bit clearer, because we see then that we're subbing g of x into f of x. So we have g of x inside of f of x. So what I like to do there is write out f of x, and where we have an x, I put in brackets. So I have 2 bracket instead of x, and then -5. Because instead of just inputting x into our function, we are inputting g of x. G of x. So we put g of x into our bracket, and g of x is equal to x squared minus 2x. And this is the expression that we will multiply out and simplify. So f of g of x is equal to 2x squared minus 4x minus 5. And now we do it the other way around. We're going to see what g of f of x is. So we put brackets where the x's are in G. So we have something to be squared minus 2 by something, because g of x is x squared minus 2x. And what do we put in those brackets? We put f of x. And f of x is just equal to 2x minus 5. So they go inside the brackets. Now let's multiply out this expression. So that just multiplies out to be 4x squared minus 20x plus 25 minus 4x plus 10, which is the same as 4x squared minus 24x plus 35. So that is g of f of x. So as you can see, f of g of x is not the same as g of f of x. So the order in which we did things matters. Now, of course, you might be saying to yourself, well, can they be the same? And maybe, yes, they can be at a certain point, because if you were to draw graphs of these two functions, they might intersect at some point. You know, you might have one U-shaped graph here and another one here, and maybe they have a point of intersection. And at that point, yes, f of g of x would be equal to g of f of x. But as you can see, in general, for most points, they aren't the same. And this question is just asking in general. Now, you might have seen in textbooks or heard from your teacher that function composition is not commutative. And all that means is that the order matters, because commutative is to do with the order of operations, and commutative operations mean that the order in which you do them doesn't matter. So saying that the composition of these functions is not commutative is basically just saying this, that f of g of x is not equal to g of f of x because the order matters. And the question could be phrased like that. It could ask you to show that the composition is not commutative, and you would basically just do out the same steps that we did in part 2 there. So I hope that makes sense, and hopefully this video maybe cleared up any confusion you might have had with composition of functions.